Dear students, in this video we are going to discuss about the most important topic of mathematics. Actually, we are going to discuss about the branch of mathematics called calculus. Okay? What is calculus? Calculus is that branch of mathematics which makes calculations easy. Okay? There are some calculations which you cannot perform without the help of calculus. You might have already used calculus in physics while calculating velocity or finding work done. I don't know. I hope you have done it. Okay. Calculus has two branches divided into two parts. One is the differential calculus. Differential calculus is divided into two parts. One is differential calculus and another is integral calculus. Integral calculus. In differential calculus, we study let me give you an example. Suppose what is this? This is a chalk. Okay. Whenever I write on the blackboard with the help of this chalk, what happens? It breaks into teeny parts. Alright? Like this, teeny parts, it breaks into teeny parts. When we study the teeny parts of this whole chalk, that is differential calculus. Now, if these teeny parts are collected again and combined together to give this whole job, that job is done by integral calculus. We sum up the teeny parts to get the whole, that is integral calculus. Okay? So, in differential calculus, we study parts by parts. In teeny, differentiation means study the teeny parts. Small incidents. Okay? And integration means summing up the teeny parts into a whole. Okay? Okay, we'll discuss it later. We'll know much more things. To begin with calculus, now, to study calculus, we should be acquainted with some terms like variable, constant. So, what is a variable? A variable is a symbol which takes different values in the same part of a discussion. And what is a constant? Constant is a symbol which takes the same value either in the whole part of a discussion or in the whole discussion. Let me give you an example. Suppose I go to a school with some questions. Question number 1. What is the name of the school? Okay, my first question is, will ask about name of school. Suppose my expected answer is A. Number 2, which class do you read in? That means name of class. Then number 3, what is your name? That is name of student. Suppose this is something B and this is X. So I went to a school with 3 questions. My first question, I will ask to every student of the school. My first question is, what is the name of your school? Second is, which class do you read in? And the third is, what is your name? So I have made a table, and on the table my first question answer head is denoted by A. That means I have represented the whole set of answer with the symbol A. Then the second question is headed by B. That means I symbolize the second answer of the second question as B, and the third question as X. Okay. Suppose I visit 3 classes of the schools: class 8, class 9, and class 10. Now, for my first question, I will get the same answer throughout the school. Whatever the name of the school, all the students will say the same name. Okay? So I will get the same answer. That means A will have a single value. Whenever I enter class 8, all the students of class 8 will say that they read in class. That means in the whole part I am getting the same answer for question number 2. That means in this part B has a single value. But whenever I move from this part to this part, that means to class 9, the answer alters. B takes another value, but in the whole part it takes the same value. Then I move to class 10 and I get another answer as 10. I read in class 10 and B gets another value, but in this whole part it takes the same value. Regarding the third question, it is expected that each and every student of the school will answer differently. Different students may have different names. So, the symbol A takes same value throughout the discussion. Symbol B takes same value in the same part of a discussion, and then in another part it may take another value, another part, another value. Okay, but in a single part it takes a single value. And the symbol X takes different values. It varies at each point. Okay? It varies at each point. Point means a student here. So it differs from student to student. So X is a variable here. A and B are constant. But there are different types of constants. A is absolute constant. Absolute constant. A is called absolute constant. That is the symbol which takes the same value throughout the discussion is called absolute constant. And B is called arbitrary constant. It takes different values in different part of the discussion, but same value in the same part. Okay? Such type of constant is called arbitrary constant. And X is variable. Okay? Next, neighborhood. What is neighborhood? So what is neighborhood? Neighborhood is the area where I belong. Okay? My neighborhood means the area, means an area where I belong. Is neighborhood a fixed area? No. Why? Because if in Hailakandi I am asked, where do you belong from? I said, yeah, I belong from Projecti Road or Okilpoti or whatever. If I have been asked in Silchar, my answer would have been Hailakandi. If I am asked at Delhi, my answer would be Assam. If I am asked at London, my answer is India. So my neighborhood differs according to the question. Okay? From where it comes or as per the situation, my answer differs. So neighborhood is not a fixed area. Just like us, a number also has its neighborhood. Suppose A is a number. Whenever we speak about neighborhood of a number, it means an open interval. Okay? An open interval A minus delta to A plus delta. Where delta is a very small positive quantity. This length is delta. This length is delta. Okay. So this area is known as the neighborhood of the number. So neighborhood of a number a is the upper interval a minus delta to a plus delta, where delta is a very small positive quantity. Okay? This is called neighborhood of a number. Next, you should know a symbol. This symbol, this means in mathematics, this means tends to. In mathematics, this means tends to. Okay? Like this, x tends to 2. What does it mean? X tends to 2 means x is approaching to 2. Or in other words, we said that x is very nearly equal to 2. That means the value of x is almost 2, but not 2. It's not equal to 2, but it's almost 2. Then what does it mean? X tends to 2 means x takes values in the neighborhood of 2. Value of x is very near to 2. That means either it is a bit smaller than 2 or a bit greater than 2. Either it lies very near to 2 on the right side or very near to 2 on the left hand side. Okay? So this part of the neighborhood of 2 is 2 minus delta to 2 plus delta. This part of the neighborhood is called right neighborhood, and this part is called the left neighborhood. So the right neighborhood contains values just greater than 2. This is minus, this is plus. And the left neighborhood contains values just less than 2. So left neighborhood values are less than 2 and the right neighborhood values are greater than 2. So whenever I say x tends to 2, it means x is very nearly equal to 2. It's almost 2 but not 2. So either it is a bit less than 2 or a bit greater than 2. This is the meaning of tends to 2. That means whenever we say that a variable x tends to a, it means x is almost equal to a, or in other words, value of x lies in the neighborhood of a. Then the most important thing, limit. What is limit? We are going to study limit. Okay, before going to define limit, let me give you an example to understand what is limit. Suppose you target an arrow, you fire an arrow to me, okay, and the distance between you and me is 100 meters. The arrow you fire has peculiar characteristics. It always falls half the distance it has been targeted. It always falls half the distance it has been targeted. So we are standing 100 meters apart. So you have targeted for 100 meters, but it falls at 50 meters. Okay. Then you come to that 50 meter and again take the arrow and target to me. Now you target for 50 meters, but it falls at 25 meters. Okay. Then you again come to that point and pick up the arrow and again target to me. This time you target for 25 meters and it falls to 12.5 meters. In this way, you go on targeting the arrow on me. What do you think? Will you ever be able to hit me with such an arrow? No, practically it's not possible. You can never hit me. Even I am at the distance of nanometer from you, you cannot hit me practically. Okay? But theoretically, let me see what it happens. For the first time, you fire for 50 meters, then for 25 meters, then for 12.5 meters, then in this way, you go on firing. Okay? So, if you become able to hit me, the sum total of the distances must be equal to 100. Okay? Now, if we look into this is a progression. What type of progression is this? This is a geometric progression. 50, then 25, then 12.5. So it's a geometrical progression with common ratio half. With common ratio half. Okay. Now, sum of an infinite GP, if you can remember, sum of an infinite GP is A by 1 minus R. This is equal to 50 by 1 minus half equal to 100. It means if you can fire the arrow infinite number of times, then you will be able to hit me. So practically it's not possible, but theoretically it's possible. Okay, this idea is called limit. Practically you cannot hit me, but theoretically I have shown that you will be able to hit me if you hit infinite number of times. This is the idea of limit. Okay, where we are not being able to find the practical value, but practically we are not able to find the value, but theoretically we can find it. This is the idea of limit. We use limit in various situations to find velocity. You find velocity, instantaneous velocity, and this is possible only because of limit. Okay? Practically to find the instantaneous velocity of a body is not possible. To find the velocity of a body at a particular instant is not possible, but we can find it theoretically. Okay? Okay. Let us discuss with some more examples. Limit is written in this way, either LIM or LT. Okay? We write in this way, limit x tends to 2, 1 plus x. Okay, what is its value? And what does it mean? What does it mean? It means when x is very nearly equal to 2, that means when the value of x is almost 2, what is the value of 1 plus x? So when x is almost 2, value of 1 plus x is almost 3. This is what limit is. Okay, while value of x is almost 2, value of 1 plus x is almost 3. Okay, either you take a value of x a bit smaller than 2, then the value of 1 plus x will be a bit smaller than 3. If we take value of x a bit greater than 2, then the value of 1 plus x will be a bit greater than 3. And on approximation it becomes 3. Okay. Limit x tends to 5, x square. What will be limit x tends to 5, x square? When x is almost 5, x square is almost 25. Okay? This is the limiting value of x square when x tends to 5. Next, limit x tends to 2, greatest integer value of x. This is very crucial. You see. What will be this? When x is almost 2, then the greatest integer value of x is what? You see here, x almost 2 means the value of x lies in the neighborhood of either in the right neighborhood or in the left neighborhood. 2 plus delta to 2 minus delta. When x is in the right neighborhood, x is in this area, either in the right neighborhood or in the left neighborhood. When x is in this area, that means when x takes values just greater than 2, then greatest integer value of x will be 2. But when x takes values from the left neighborhood, that means when it takes values just less than 2, then its greatest integer value will be 1. Thus, they differ in values. Now, what can I say? What is the limit value? 2 or 1? In that case, we say that the limit does not exist. Okay, we say the limit exists when either it takes values from the right neighborhood or from the left neighborhood. If the limit value is the same, both for left and right, then we say that the limit exists and the common value is called the value of the limit. But if the right hand value and left hand value are not the same, then we say that the limit does not exist. When x takes values from the right neighborhood, we say that x tends to 2 plus. That means a bit greater, 2 plus. This is called right hand limit. This is called right hand limit. So the right hand limit is 2 here, and when x takes values just less than 2, we write this in this way: x tends to 2 minus. That means a bit less than 2, and this value will be 1. Here, right hand limit and the left hand limit are not same, so we say that the limit does not exist. In this case, that means in this case we cannot find the limit value. Okay, and this is known as existence of limit. For existence of limit, the left hand limit and the right hand, the left hand value and the right hand value should be the same. The left hand limit, right hand value limit both have the same value, same and finite value. Then we say that the limit exists. Okay. Now suppose, let me give you one more example. Limit x tends to 1, x square minus 1 by x minus 1. What will be its value? Okay. When x is very nearly equal to 1, then 1 minus 1 will be 0. It's almost equal to 0. And in that case, we cannot find the limit. These are called indeterminate forms. 0 by 0. On putting the value, numerator becomes 0, denominator also becomes 0. Or we may also find infinity by infinity form, 0 to the power 0 form, infinity to the power 0 form, 0 to the power infinity form, infinity to the power infinity form. So, generally, these forms of limits come in exam. Okay? We will deal specially with these types of limits: 0 by 0 and infinity by infinity. Okay. So this is a 0 by 0 form limit. So how to evaluate? You see here, I am evaluating the limit. If you factorize, this is a square minus b square form. So will be a minus b into a plus b. Now this x minus 1 will cancel out. Why cancel out? Because we know that we cannot cancel with 0. But here x minus 1 is not 0. You are saying that x tends to 1. X tends to 1 means x is almost equal to 1 but not equal to 1. Not exactly equal to 1, it's almost equal to 1. Okay? So, since it's almost equal to 1 and not equal to 1, so x minus 1 may be almost 0 but not exactly 0. Since it's not exactly 0, so we can cancel it out. So, we will get x plus 1 and its limit value is 2. Here, this is also this is another example where we are able to find the limit value, but it's impossible to find the exact value. For exact, when x is exactly equal to 1, you cannot find the value. Okay? So this form is known as 0 by 0 form. Let me give you one more example. So limit x tends to 2, x square plus x minus 6 divided by x square minus 5x plus 2. In this form of limits, you will see polynomial by polynomial and limit tending to a finite value. 2 is a finite value. Limit tending to a finite value and polynomial by polynomial. On putting the finite value, 4 plus 2, 6 minus 6, 0. 4 plus 2 6 minus 6 0. So this is 0 by 0 form. Okay, limit tending to a finite value, polynomial by polynomial. In this case, what we do, we factorize. To factorize both numerator and denominator. On factorization, this becomes x plus 3 into x minus 2, and this will be x minus 1 into x minus 2. So x minus 2 cancels out. This becomes x plus 3 by x minus 1. Okay. On putting the limit value, what is the limit value of x? Limit value of x is 2. On putting the limit value, when we put the limit value, we don't write limit here. What did I say? When we put the limit value, then no need to write LIM limit here. So the value is 5. Okay? Thus we find the limit as 5. So when to apply this factorization method? Polynomial by polynomial, limit tends to a finite value, and putting the limit value, this is of the form 0 by 0. In that case, we factorize both numerator and denominator, put the limit value and cancel them out. Okay, let us solve some examples. Let's take one more example. Limit x tends to 2, x square minus 5x plus 6 divided by x square minus 5x plus 2. Almost the same example. So this is of the form polynomial by polynomial, limit tends to a finite value. On putting the limit value, 4 plus 6 10 minus 10 0. 4 plus 2 6 minus 6 0. So polynomial by polynomial, limit tends to a finite value, and 0 by 0 form. We factorize both numerator and denominator according to the rule. Okay, x minus 2 cancel. Putting the limit value, so minus 1 by 1 is equal to minus 1. So our limit value is minus 1. So we find the limit as minus 1. So this is one form. There is another form, infinity by infinity. Let us take an example. Limit x tends to infinity, 2x cubed minus 5x plus 3 divided by 3x cubed plus 4x squared minus 1. So this is also the form polynomial by polynomial, but the limit does not tend to a finite value. Limit tends to an infinite value, infinity. This is defined. Okay, this is not of that form. This is polynomial by polynomial, it's okay, but limit tends to infinity. Now if we put infinity in place of x, infinity cube is infinity. 5 into infinity, infinity. So infinity minus infinity, is it 0? No. Because infinity is not a finite quantity. Okay? What is infinity? Infinity means it's too large. Okay, means it's too large. But how much large? We don't know. As we don't know how much large, so we cannot subtract a too large from a too large. A too large minus too large is too large. Alright? So infinity minus infinity is infinity, infinity into infinity is infinity, infinity plus infinity is infinity. Alright? Infinity by infinity is infinity undefined. Okay? So infinity minus infinity, infinity plus 3 is infinity. Infinity plus infinity is infinity, minus 1 is infinity. So this is of the form infinity by infinity. So polynomial by polynomial, limit tends to infinity. In that case, what do you do? Listen carefully. This is the rule. Okay. In that case, we find the highest degree term in the numerator. So what is the highest degree term of the polynomial in the numerator? It's x cube. So we divide both numerator and denominator with x cube. We divide with the highest degree term in the numerator. Okay. So here the highest degree term in the numerator is x cube. We divide both numerator and denominator with x cube. So in dividing with x cube, this becomes 2. This becomes 5 by x square plus 3 by x cube. 3 plus 4 by x minus 1 by x square. Okay. Now I'm putting, so this is not 2, this is infinity. Now I'm putting the limit, this becomes 2 minus 5 by infinity square means infinity, plus 3 by infinity cube is infinity, 3 plus 4 by infinity minus 1 by infinity. Now what is the value of 5 by infinity? That means if you divide 5 things into infinite parts, how much will you get in each part? Each part will be very, very small, that means 0. So any finite quantity by infinity is 0. Remember that thing, any finite quantity by infinity is 0. So this will be 2 minus 0 plus 0 divided by 3 plus 0 minus 0 is equal to 2 by 3. And this is the, okay. So when it is of the form polynomial by polynomial and limit tends to infinity, polynomial by polynomial, limit tends to infinity, what do? We divide both numerator and denominator with the highest degree term in the numerator. As in this case, the highest degree term in the numerator is x cube. We have divided both numerator and denominator with x cube. Then put the limit value, and any finite quantity by infinity is 0. In this way we get 2 by 3. So this is the rule for this method. Okay, let us take one more example. Limit n tends to infinity, 1 square plus 2 square plus dot 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 up to n square divided by n cube. Okay, do you know this sum? Okay, some of you may know, some of you may not. So let me give it. Sum of first n natural numbers, 1 plus 2 plus 3 plus dot 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 up to n, is n into n plus 1 by 2. Then sum of the squares of first n natural numbers, 1 square plus, note this sum, n square is n into n plus 1 into twice n plus 1 divided by 6. Then sum of cubes of first n natural numbers, n into n plus 1 by 2 whole square. Alright. So this sum will be n into n plus 1 into twice n plus 1 divided by 6. So put the sum here. Alright. On simplification, divided by 6n cube. So this is a polynomial, this is another polynomial, polynomial by polynomial, limit tends to infinity. N is the variable here. So this is of the previous rule. Okay, so what to do in this case? In this case, we are to divide both numerator and denominator with the highest degree term in the numerator. So what is the highest degree term in the numerator? What type of polynomial is this? N into n, that means it is a cubic polynomial. Therefore, the highest degree term in the numerator is n cube. N into n, on expansion, it will become n cube. So we are to divide both numerator and denominator with n cube. Okay. Before that, we may cancel this and this n. This will make it easy. So this is n plus 1 into twice n plus 1 divided by 6 n square. Now the highest degree term is n square. So we divide both numerator and denominator with n square. You may divide this step with n cube also, no problem. So n square. We will divide this part with n into n. We divide this part also with n. So n into n will become n square. So n by n is 1 plus 1 by n into 2 plus 1 by n. So we have divided here by n and here by n. So n by n into n means n square. We have divided by n square. So denominator is also divided by n square. Now putting the limit value. Limit tends to infinity, we put the limit value there. So this will be 1 plus 1 by infinity into 2 plus 1 by infinity. Divided by 6. Right? So 1 is a finite quantity. Any finite quantity by infinity is 0. So this is 0, this is 0. So this is 1 plus 0 into 2 plus 0 by 6. This means 2 by 6 equal to 1 by 3. So we find the limit as 1 by 3. Okay. Let us take another example. Sometimes you may get radical sign also. Suppose there is an example. Limit x tends to 0, a minus under root s square minus x square divided by x square. Okay, this is not polynomial, alright, because you cannot do the radical sign, so it's not a polynomial. But if we put x equal to 0, is that a? Yes, x equal to 0, then that will be a minus a, 0 divided by 0. That is, it is of the form 0 by 0. So you cannot factorize the numerator and denominator, but we can multiply with the conjugate. Okay? If we multiply, when the limit contains radical sign, we multiply both numerator and denominator with the conjugate. So this is the rule, remember it. When there is radical sign and of the form 0 by 0 or infinity by infinity, you multiply both numerator and denominator with the radical sign. With the conjugate. So what is the conjugate of this? A minus root over s square minus this x square. Conjugate of this is a plus root over s square minus x square. So limit x tends to 0. We multiply with the conjugate. multiply with the conjugate. So a plus b into a minus b means a square minus b square. So this will become a square minus x square divided by x square into a plus root over s square minus x square. So x square by x square into a plus root over. Now if we put cancel x square, so 1 by a plus root over s square minus x square. Okay. Now we put the limit value x equal to 0. Now we put the limit value here. Okay. So we have put the limit value, so no limit will be there. So this will become 1 by a plus a is equal to 1 by twice. Alright. Then another one. Infinity form. Limit x tends to infinity. Root x into root x plus 2 minus root x. So here limit tends to infinity, infinity into infinity minus infinity, that is infinity into infinity form, infinity into infinity form. Here also we multiply both numerator and denominator with the conjugate. So what will be the conjugate of root x plus 2 minus root x? Conjugate of root x plus 2 minus root x is root x plus 2 plus root x. So we will multiply both numerator and denominator with that quantity. So multiplying with the conjugate, tends to infinity. Plus. So here again a minus b into a plus b is a square minus b square. X tends to infinity. This will be 2 root x because x minus x will be cancelled. Now if we put the limit value, this will be infinity by infinity plus infinity means infinity. So this is of the form infinity by infinity. So what we will do? We will divide both numerator and denominator with the highest degree term in the denominator, that is with root x. So dividing with root x, the numerator will be 2 and the denominator x plus 2 by root x plus 1. Okay. This is equal to limit x tends to infinity to root x plus 2 by root x. If we take it under the same rule, then it will be root over x plus 2 by x, and on simplification x by x is 1 plus 2 by x. Root over x plus 2 by x, so x by x is 1 and plus 2 by x plus 1. On putting the limit value 1 plus 2 by infinity plus 1. 2 by infinity is 0, so this will be 2 by 2 is equal to 1. So we find the limit as 1. Then take another example. Limit x tends to infinity 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 1 by twice n minus 1 into twice n plus 1 okay into twice n plus 3. Limit n tends to infinity. So 1 by 1 into 3. Okay. Here the difference is 2. Let us multiply each part with 2 and adjust by half outside. So this will be 2 by 1 into 3 plus 2 by 3 into 5 plus 2 by 5 into 7 plus the last part is 2 by twice n plus 1 into twice n plus 3. Let me write the term prior to the last term, and this will be, you see it's going on increasing by 2, 1, 3, 5, 7, 9 this way. So if we come from that side, this will decrease by 2, 5, 3, 1, 7, 5, 3. Alright, so twice n plus 1 minus 2 will be twice n minus 1, and this will be twice n plus 3 minus 2, that means twice n plus 1. Alright, now this can be written as 1 by 1 minus 1 by 3. You see, LCM will be 1 into 3, and in the numerator there will be 3 minus 1, 2. Plus 1 by 3 minus 1 by 5. Plus 1 by 5 minus 1 by 7. Plus dot 1 by twice n minus 1 minus 1 by twice n plus 1 plus 1 by twice n plus 1 minus 1 by twice n plus 3. Alright. Now you see this 1 by 3 minus 1 by 5 1 by 5 minus 1 by 7, here will be plus 1 by 7, then here will be minus 1 by twice n minus 1 minus 1 by twice n plus 1 plus 1 by twice n plus 1. All these will get cancelled. We will be left with only the first term and the last term. So 1 by 1 is 1 minus 1 by twice n plus 3. Okay. On taking LCM, half into twice n plus 3 minus 1. Alright. This is equal to limit n tends to infinity half into, so twice n plus 2 divided by twice n plus 3. Okay. Now limit tends to infinity. If we put n for infinity, infinity for n, this will be 2 into infinity means infinity plus 2 is infinity by infinity. So what will we do? We will divide both numerator and denominator with the highest degree term. So what is the highest degree term? N here. So we will divide both numerator and denominator by n. Okay, this is equal to limit n tends to infinity half. So 2 plus 2 by n divided by 2 plus 3 by n. This is equal to half on putting the limit value 2 plus 2 by infinity 2 plus 3 by infinity. So any finite quantity by infinity is 0. So this will be 2 plus 0 by 2 plus 0. So this will be half. Okay. In our next video we will continue discussing about limit. Now it's your homework time. Your homework is class book page 304 under example 1 Roman 1 Roman 2 Roman 3 Roman 5. Then page 312 exercise 16.1 question number 6 Roman 1 2 Roman 5. Then question number 7 Roman 1 to Roman 4. Okay. You solve all these problems. Question number 6 Roman 1 Roman 2 Roman 3 Roman 4 Roman 5. Question number 7 Roman 1 Roman 2 Roman 3 Roman 4.